We need to start out with simple interest. Simple interest, I actually think, is the most difficult concept of the unit, even though it's simple, just because there's more complex processes in it. So in simple interest, first thing you need to know is ordinary versus exact. Yes, 360 days in a year for ordinary, 365. Now, if you're counting days, if money has been in there from like January 1st to December 30th, that's 364 days. You still use 364 days. It just goes over 360 for ordinary. So it's weird because you're still counting days. You're counting days exactly. It just goes over 360. Next is the U.S. rule for partial payments on an account. So now remember, if we're not told ordinary exact, we always assume ordinary. So our U.S. rule for partial payments, this again is that example where somebody takes a loan, Pat borrows $4,000 on May 19th at 6% for 90 days. On June 21st, Pat pays $1,000. On July 18th, pays another $1,000. Find one, the balance due at maturity. 2, total interest paid. And 3, interest saved by making partial payments. No problem, right? Somebody pull out their magic little table on page 396 for the days of the year, please. This all starts out on May 19th, which is what day of the year? Day 78. 139? Okay, that sounds better. 396. Yeah, page 396 is your calendar. So that was when all this stuff started. So there's nothing to do there. That was the start of it. The next day is June 21st, which is day 172. 172 minus 139 is 33 days. Of course, there was a $1,000 payment made, but before we can consider the $1,000 payment, we must find interest. On $4,000, I was nice here and did 6%. 0.6, 33, 360. $22 in interest. Does that look right? So we add that that $22 to the 4,000 balance. That is the balance before the payment. And then we subtract the $1,000, $3,022. That's the balance after the payment. Our next date is July 18th, which is 199. So yes, we will subtract 199 minus 172 to get 27 days. So what's going in this lovely formula? 2022 times 0.06, 27 over 360. Good. Giving us $13.60 in interest. So 3022 plus 1360 is $3,035.60. That is before the payment. And then subtract the $1,000 payment. $2,035.60 is the balance after the payment. And then maturity. We're going to have 90 days minus 33 and minus 27, which gives us 30 days left. Why did I subtract 33 and 27? Those are the days that have already gone by. So our interest is $2,035.60. 0.06 times 30 over 360. $10.18 in interest. So 2035.60 plus 1018 is $2,045.78. That's my answer to part one. That is my balance due at maturity. Part two, part B, total interest. If you add up all your interests, you get $45.78. Part C, the amount saved by the partial payment. Well, part C, we must first find full interest amount. Perfect. That full interest amount is the 4,000 times 0.06 times 90 over 360, which is going to be $60 in interest. So 60 minus the actual amount that was paid of $45.78 is $14.22 saved. What do you think? Questions? Comments? Please for mercy. What's that? One just like that? Yeah, probably. I might change numbers. Pat extends, oops, let's put a date in here. On November 23rd. Pat extends a 7.3% 120-day loan for $7,000 to Sam. On January 8th, Pat discounts the loan to the bank at 8.5%. Find Pat's proceeds. And that is break time. So let's take a break. When you come back in early, if you want to chip away at that, feel free. Otherwise, we'll be back at 7. So this is discounting a note. Step 1 is the maturity value of the original note. So to do that, we have to find the interest, which is going to be on the $7,000 principal. What rate? 7.3%, so 0.073 for 120, the full amount. So 7 times 7.3. We get $170.33. That would be the interest on the original loan if it went full term. So we add that to the 7,000. So it's $7,170.33 is the maturity value. What is step 2? Well, we find the discount period. The 23rd of November is what day of the year? 3/27. Now, the next day is the 8th of January, which of course is day 8. So what we have to do is we have to go from November to the end of the year, 365 minus 327, which is 38, right? Plus the 8 to get to January is 46 days. That's the days gone by. The discount period is going to be the term of the note, the 120, minus the 46 days gone by. So 74 days are the number of days left. That is the discount period. Step 3. Use that information to find the bank discount. So that discount will be the maturity value, 7170.33. Oops, get back here. Times the bank discount rate of 0.085. 74 over 360. 7170.33. Not that I don't trust you, but I'm this far already. Yeah, 125.28 is correct. That's the bank discount. So the proceeds are the maturity value minus the discount. So $7,045.05 are the proceeds. The other somewhat difficult task in simple interest, find the effective rate on a $6,000 simple discount note at 8% for 90 days. Effective rate on a simple discount note. First, find the discount. Which is interest. That'll be the 6,000 times the rate of 0.08, 90 over 360 again. Giving us $120 in interest, $120 discount. Now remember, since this is a discount note, whoever's doing the borrowing doesn't actually get 6,000. It's 6,000 minus the $120 discount. So it's $5,880 is what they actually receive. So the effective rate yes, use I equal PRT. Discount is our interest, 120, but instead of 6,000, we use our proceeds of 58.80. We're looking for a rate, and it's still 90 over 360. So we're going to combine the 58.80 with the 90 over 360, which is what, 1470? And then divide by the 1470. We have 0.08163. Move the decimal point. That's 8.163%. Now, I didn't tell you where to round it, so we assume it is hundredth. So 8.16%. That's pretty much the worst of the simple interest stuff. I really think the compound interest is the easiest topic in the unit. Well, that's because this week's stuff and last week's stuff were so tight together, you're seeing it a second time. Like I said, I really think simple interest is the toughest part. All big formulas is all. Yep. So for our compound interest, we have a present value, which is now, future value, which is some point in the future. Then, of course, in between there, we have rate, compounding, and time. So let's say that Sam invests $4,000 at 9% compounded quarterly for 9 years. Find A, future value or maturity value. and B, the effective rate. Future value is pretty simple. We're going forward, so we're going to multiply. Our future value is equal to the present value, which is 4,000, times, how many parentheses? Just one question. 1 plus 0.09 is her rate, divided by 4, because it's quarterly, to the power of 4 times 9, which is 36. And that, not for future value, not for compound interest. That's only for annuities. So 4,000 times, parentheses, 1 plus 0.09 divided by 4, close to the power of 36. We get 89, 11, 27. That's our future value. Effective rate. What's our biggest rule of effective rate? If the term is less than a year, we use the actual term or actual time. If the term is more than a year, we only use 1 year. So I have to recalculate the future value for only 1 year. No, Banker's rule is only for simple interest. So I've got the 4,000. Come on. Times 1 plus 0.09 divided by 4, close power 4. 43, 72, 33. So yes, to get our amount of interest, we subtract the original 4,000. That's 372.33. So our effective rate, the interest is 372.33 equals our principal of 4,000. Looking for the rate, our time is 1 year. So 4,000 times 1 is just 1, so I'm not even going to bother doing that. Or so 4,000 times 1 is just 4,000, I should say. So I'm not going to bother doing that. We're going to divide by the 4,000. So 372.33 divided by 4,000. 0.09308 equals the rate. Move the decimal, that's 9.308%, which is 9.31 if we're going to 2 decimal places. That's it. That makes sense to them. This is actually kind of fun when it makes sense. When it doesn't make sense, it's torturous. I understand. Kim wants to have $9,000 in 10 months, 10 moths, 10 months. How much should Kim invest at 7% compounded monthly? And so that's A. B, what's the effective rate? What formula do I use for part A? I am looking for the present value for compound interest. It's $9,000 divided by, because we are going from the 9,000 is at the end of the timeline, and we want to look to see how much we need to have now. So we're going backwards, we have to divide. Parentheses, 1 plus 0.07 divided by 12, because it is still monthly. That number is the number of periods in a year. The 10 comes into it because it's only going to be in there for 10 periods, 10 months. So 9,000 divided by 1 plus 0.07 divided by 12, power of 10. 849 or 8491.46. That is the present value. That's how much needs to be saved right now. Now, if I want to figure out the interest, the amount of interest, it's 9,000 minus the 8491.46, which is going to be 500. $508.54 is the interest. So for the effective rate, the 508.54 goes in for the interest. What goes in for my principal? What I started out with is the 8491.46. Times R times 10/12. Right? So we have to take that 8491.46 times 10/12 to give us a good decimal thingy. 7076.22. So we're going to divide by 7076.22. Now what I'm going to do is this. I'm going to do the 508.54 divided by that previous answer, which is the 7076. That way I get all those decimal places in it. 0.071866, which is 7.1866% or 7.19% is the effective rate. What y'all think? Good stuff? And then the last part is the annuities that we've already reviewed. Remember, during the accumulation phase, we have two types. We have ordinary annuity, which is the ones we did mostly tonight, the ones we did all the time when we did accumulation. And then there's the annuity due, which has that extra little factor on it. So that's only if we know the payment, we're looking for the future value. We have this formula. Remember, at the end, we have this extra little term, 1 plus R over N, no power on it. And then, of course, we have liquidation phase, which is what we did tonight. And then we had the combination problems, which is what we did after our first break, where you have both accumulation and liquidation. Have a good week. If you guys got all that down, you should be ready for the test. The biggest thing on the test is take your time, read the problems carefully, and make sure you know what type of problem it is. Look to see. I mean, the simple interest most people catch, but they confuse the compound interest and the annuities. The compound interest, future and present value, and the annuities, what's the big difference? Regular payments. If it has regular payments going in or coming out, it must be an annuity, which is the big long formula. Okay, so remember that quiz is due tomorrow. There's a homework due for next Wednesday. There will be an extra credit quiz due next week. Have a great weekend. I think you guys have suffered enough for one day.